All right, so this is day 2, worksheet 2, mass-to-mass calculations. These are going to get a little long. In fact, I already recorded part of one of this and my writing was too big, so I've actually reset this. This is my second time, so trust me when I say start out small. So in order to make things and give myself a little bit more space, I'm going to do my knowns and unknowns in a little bit different way. I'm actually going to annotate the question. So what is the mass of iron is my unknown. 96 point, doesn't say point anything, 96 grams of iron 3 sulfide is my known. So I've got that established. So the first thing I'm going to do is put my known over 1, 96 grams, and it gives me the formula right here, Fe2S3, put it over 1. Now, if I have grams of iron 3 sulfide on the top, I need to have it on the bottom. And to save myself a little bit of time, I went ahead and did the calculations, but of course you would have the weight of an iron times 2 and the weight of sulfur times 3. And when you weigh that all together, that's 207.91 according to my calculations, and that's Fe2S3. So I can put that number right down here, so my grams will cancel off. In 1 mole of Fe2S3. Now I need to solve for the mass of iron, so I'm definitely not ready yet. If I have 1 mole of Fe2 on the top, I'm going to need to have the same thing on the bottom. So now I'm going to go to my equation, and I'm going to look to see what coefficient I have in front. Well, there's nothing there, so it must be 1. So 1 mole Fe2S3. Now, there's 1 mole of that per 2 moles of iron. And again, I get that right from my equation here. Make sure my things are canceling off. Okay, I've got grams, that cancels off. I've got 1 mole of this, which is canceling off, and there's that. I'm to 2 moles of iron. My unknown says I need the mass. So I'm going to need to have another conversion unit. So 1 mole of iron weighs 55.85 grams of iron. Now these units are canceling off, and I'm left with grams of iron, which is what I need to find for my answer. So to calculate this, it's going to end up being 96 times 1 times 2 times 55.85 divided by, and of course it'd be 1 times 207.91 times 1 times 1, which of course is going to just give you 207.91. Now I'm going to stop the video here for a second, do some calculations, and I'll put my answer right there. Okay, the answer I got in my calculator is 51.5761 blah 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 blah. Now I go back to my significant figures. Right there. Decimal is absent, so I'm going to start from the Atlantic side, which means going in this direction. And the first number is a 6 and a 9, so I need 2 significant figures, which means my final answer is going to be, decimal's present, there's my first significant figure, here's my second one, I got a round, it's followed by a 5, so that'll end up being a 2. So I'm going to have 52 grams of iron are needed for this reaction. And there's my box around it. Okay, here's the next one. I've got a little bit more room here, so I am going to write my knowns and unknowns. I prefer to do it that way because sometimes it's still a little bit confusing when you do the little question mark and label a known. So my known is I have 48 grams of magnesium. And I'm asked to find how many grams of magnesium oxide. will be formed according to the following equation. So this makes it nice and easy, and I'm going to take my known, 48 grams of magnesium over 1. Magnesium, the G stands for grab my periodic table, and I look it up, and magnesium is 24.31 grams of magnesium per 1 mole of magnesium, because I just got it off the periodic table. So if I have 1 mole of magnesium on the top, I'm going to need to have moles of magnesium on the bottom. I go to my equation, and I see that there are 2 moles of magnesium needed for this chemical reaction. So 2. And now I'm looking for my unknown, which is magnesium oxide. So then I go over here, and I see that I also have 2 moles of magnesium oxide. Let's cancel off my units and see if I'm ready to put it in the calculator. Grams of magnesium, mole of magnesium, mole of magnesium. I'm left with mole of magnesium oxide, and that's what I need for my answer. So I'm ready to put it in the calculator, and when I do that, I get 80 times, whoops, don't need that. Basically, I get 80 grams of magnesium oxide. Now I need to stop and say, okay, I need 2 significant figures. 1, 2. Now, if I look at this, decimal is absent. So I start from the Atlantic side. I hit my first non-zero number, so there's 1. So this number won't work the way it is. If I do 80 point, decimal's present, I start from this side, and now I've got 1, 2 significant figures. So my answer is going to be 80 point grams magnesium oxide. Another way you could write this, if you wanted to use scientific notation, would be 8.0 times 10 to the 1 grams of magnesium oxide. So you could show your answer in either way. These would both be correct. All right, so this is our last problem, and I'm going to go ahead and read it and work the problem. If 11.5 grams of chlorine reacts with aluminum, how many grams of aluminum chloride will be formed according to the following reaction? So it looks like my reaction is already balanced. I'm going to do my knowns and my unknowns. I've got 11.5 grams of chlorine. Now I'm going to look at my formula here. It's chlorine and it's Cl2. I want to be sure that I put that in my calculation. My unknown is how many grams of aluminum chloride, and I've got the formula written right there. And I'm ready to start. So 11.5 grams of Cl2. And now I'm on to the next part. Well, if I've got grams of Cl2 on the top, I need to have grams of Cl2 on the bottom. I need to be sure that I'm calculating how many 2 chlorine, not just 1. So it'll be Cl times 2, and that equals 70.90 grams. So 70.90 grams in 1 mole of Cl2. If I have 1 mole of Cl2 on the top, I'm going to need to have moles of Cl2 on the bottom. I see that in my reaction I've got 3. So 3 moles Cl2, and I need to find out aluminum chloride, and that's right here, and I've got 2 moles of that. So we're just looking for a ratio of how many moles per the other. And I'm going to double check and make sure that these are all crossing off. We've got 1 moles of chlorine, moles of chlorine. I'm left with 2 moles of chlorine. It looks like I'm not ready to go ahead and put this in the calculator yet, because I'm left with moles of aluminum chloride, and in my thing here it says I have to get grams, so I need one more conversion factor. So if I've got mole of aluminum chloride on the top, I have to have mole of aluminum chloride on the bottom. And I have to go ahead and calculate the weight of that. And of course that's going to be aluminum plus chlorine. And we're going to have 3 of those. And by my calculations, I have 133.33 grams of aluminum chloride. So I can take that number and just pop it right up here. Now, these are canceling off and that's canceling off, and I'm left with grams of aluminum chloride, which is what I need. So now I'm ready to put it in my calculator and figure my answer. All right, after putting that in my calculator, I get 14.4174, blah, 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 blah. All right, look up at my known. I've got 3 significant figures, so I'm going to need to have 3 significant figures in my answer. So 14.4 grams of aluminum chloride will be my final answer. Right there. So these problems get a little bit long, but as long as you are canceling out units, you'll be golden.